Hello, everyone. Today we'll be discussing the solution to problem 2 of the USACO February 2026 Silver Contest. In this problem, you have a sequence of n buckets, and each bucket has a given capacity. And 1 gallon of milk will flow into the first bucket each second. And once a bucket is full, it'll take 1 second to flip over and pour all of its contents in the next bucket. Any milk that's poured into a bucket that's currently flipped over or does not have enough capacity is lost. And the goal is to answer queries of the form IVT, where essentially you will update the bucket I to have a capacity V. And after that, you will output the amount of milk poured out of bucket N, the last bucket, by a given time T. So now let's look at a sample test case. So here, N is 3, so we have 3 buckets. Initially, they all have capacity 1, and we have 3 queries. So the first query here is we're going to update the bucket 2 to have capacity 2, and we'll print the milk poured out of the last bucket at time 6. So after the update, we have 1, 2, 1 for the capacities, and we can just step through each moment in time to see what happens. So the first moment in time, 1 gallon of milk pours into the first bucket, which fills it up. So on the next second, it will flip over and pour its contents into bucket 2. So now bucket 2 is halfway full. Uh, so we need more milk to flow into bucket 2. So at time 3, bucket 1 fills up again, and at time 4, bucket 1 flips over into bucket 2, and now bucket 2 is full. So at the next second, two things happen. Bucket 1 fills up again, and this time, since bucket 2 is full, it flips over and fills up bucket 3. But since bucket three's capacity is less than bucket 2, that 1 gallon is lost when it flips over. So now bucket 3 is full and flips over and pours out 1 gallon. And bucket 1 also pours out into bucket 2 at this time. And this is time t equals 6. So now we stop and we see how much milk has been poured out of the last bucket, bucket 3. And by time 6, you can see that bucket 3 has poured out 1 gallon. So the answer for this test case would be 1. So now let's think about how we can approach this problem. So the main way you can approach this problem is to start from bucket 1 and work your way up to later buckets. So we can make an observation that bucket 1 fills up every A1 plus 1 seconds. And this is because it takes A1 time to fill bucket 1 up to capacity, and then the extra second is for bucket 1 to flip over. So this is the amount of time it takes bucket 1 to flip, and it will flip periodically with this time. And now for bucket 2, there are two cases, right? If bucket 2 has a lower capacity than bucket 1, then once bucket 1 flips, it will automatically fill up bucket 2. So therefore, the first flip of bucket 2 will be 1 second after the first flip of bucket 1. But then every time after that, it will repeat with the same period. So A1 plus 1 seconds. Every A1 plus 1 seconds after that, bucket 2 will flip. And the other case is when A2 is greater than A1. So it will take more than one flip of bucket 1 to fill up bucket 2. And we can actually define C as the number of flips of bucket 1 that are needed to fill up bucket 2 to capacity. And then based on this value C, we can determine the first time bucket 2 flips is at A1 plus 1 times C plus 1, because we need to flip it C times and then plus 1 for the second in which it's flipping. And then after that, the period is going to be A1 plus 1 times C. So every A1 plus 1 times C seconds after that, bucket 2 will flip. And so we can notice that there seems to be some sort of pattern in which each bucket flips. So each bucket, after the first time it flips, it seems to be flipping in a same like period. So after a set number of seconds, it will flip again after the first time. And we can actually formalize this with another observation. So let's say bucket I first flips at time F and then flips every P seconds after that. So F is the first time and P is the period. Then bucket I plus 1, the first time it flips is at F plus P times C minus 1 plus 1. And the reason is bucket I plus 1 needs bucket I to flip C times in order to be filled up. So the first time bucket I flips is F, and then every time after that, it takes P seconds. So that's how we get the formula for the first flip. And then the period, we can just multiply the previous period, P, by the number of times we need to flip, which is C. So P times C becomes the period at which bucket I plus 1 flips. And we can see that if we're able to compute all of these numbers, then using the first time bucket N flips and the period at which bucket N flips, we can determine, like, for a given time, how many times bucket n would flip over within that time. And this allows us to compute like the answer, which is how much milk is poured out by bucket n. However, we still have a problem. This approach is too slow because we have a lot of queries and updating this would be O of n per query. But we need one more key observation in order to solve this problem. And that is if we just look at F and P, it seems that they're growing pretty quickly, right? And we can actually like determine how fast they're going. So if C is greater than 1, that is if it takes more than one flip for bucket I to fill bucket I plus 1, then the period is going to be more than double the period of bucket I. And the first time that it flips is going to be more than the like period, right? So essentially you can see if every time that C is greater than 1, we double our period and it grows exponentially because of this. This means that if there are more than log of t indexes such that this C value is more than 1, then the answer is 0, right? Because the first time we flip is going to be larger than the time t. And so we only need to go through this process if there are like log of t or less indexes such that the number of times that bucket I needs to flip to fill up bucket I plus 1 is like greater than 1. So now this leads directly into our solution idea. So essentially, we're going to keep track of the indexes such that Ci is greater than 1, and we'll keep track of it in a set. Essentially, we're keeping track of all the places where the bucket needs more than one flip to fill up the next bucket. And if the size of the set is greater than log of t, then we know the answer is 0, and we can just print 0. And otherwise, we can loop through each of these elements since it's a small enough number of elements. And we need to update like the segments between two of these elements where we have C greater than 1. So between two of these elements, we know that C is equal to 1. And so essentially what this does is this adds like the difference between the two indexes, so J minus I, to the time of the first flip, and the period is not changed. And we can see this by looking at like these formulas that we derived up here. And then again, using the formulas for each index in our set, so for each index that requires more than one flip to fill up the next bucket, we have this formula here again, which we can use to update the values of F and P. And at the end of this process, we will have taken log, like O of log T steps, and we will have computed F of n and P of n, which using this formula, we can find the answer. And so what this formula is essentially doing is it's subtracting, like taking t, subtracting the first time it that bucket n flips over, dividing that by like the period it takes for bucket n to flip after that, and then adding 1 for the first time. And if this is negative, then obviously we can't have a negative answer. So we take uh the like 0, we set it to 0 if it's negative. So now let's see how we can code up this solution. So first we have code that reads in the input. And what we'll want to do first is we'll create this set of indexes. So initially, we're just going to store all the indexes where A of I plus 1 is greater than A of I. So this means the ith bucket will have to flip multiple times in order to fill up the I plus first bucket. And then we can define a function which will process the updates of like in each query and update our set of indexes. So what we want to do is the update is coming to index I. So if I minus 1 or I is currently in the set, we want to remove it. Then we can make our update. And now we can add it back if it satisfies the condition, right? So if if A of I is greater than A of I minus 1, we add I minus 1 to the set. If A of I plus 1 is greater than A of I, we add I to the set. And this just updates our index based on like the our query, setting A of I to V. So now we have all what we need to process our queries. So yeah, we can read in each query and we can first update. And here we're going to, if the set indexes is too big, so if we're using 64 as a sort of upper bound for log t, then we know the answer is 0, so we can just print 0. Otherwise, it's small enough that we can loop through each index in the set. So we can keep track of, this will keep track of the previous index in our set. And these are just the values of F and P that we're going to compute. So we're going to go through each index. And this is in the case between the two indexes in the set. We're going to add the difference in the indexes to the first flip. And the period does not change. And then we're going to determine what C is, which is the number of times that this bucket needs to flip to fill up the next bucket. And if this makes our answer too big, we can check this by like determining what our answer will be. And we're using the value of 2 times 10 to the 18 as sort of like infinity, our upper bound. If this makes it too big, we can immediately break since we know that our t is going to be less than this number anyway. So our answer is just going to be 0. We don't need to continue. And this prevents us from working with numbers that like become too large. Otherwise, we can apply the formula above, which we derived here. And yeah, we could store our current index and use it in the next iteration. And yeah, at the end, we're just going to add up all like the segment from the last index in the set all the way to the end, bucket n. And this gives us the values of f and p for bucket n. And we can just plug that into our formula here, which will give us the answer for each query. And now we can test our code using the sample test case from USACO. So I'll copy it here, and we can see that our code gets the right answer. And this code will get full credit for this problem. Thanks for watching, and I hope you guys learned something from this video.